All right, here's Chapter 9, Section 1, entitled Apply the Distance and Midpoint Formula. So, first of all, the distance formula, you can define it or you can simply state that it is the square root of the difference of the x's squared plus the difference of the y's squared. You could also just state that it is distance from point A to point B. The midpoint formula you can just write out as it's basically the averages of the x's. So you add x1 and x2 together. You add the x's together, you divide by 2. You add the y's together, you divide by 2. What it really is, though, it is the coordinate of halfway point. So it is the coordinate of the halfway point between point A and B. So down here, remember, it's the difference of the x's squared plus the difference of the y's squared. Let's take a look at the first example. All you got to do is remember that this is an x and this is an x. So you plug that in there. And it doesn't matter which order you do it in. -5 minus 3 squared plus, now the y values. Let me choose a different color here. Now we have to have the y's, the y. So now you can do -3 minus 6 squared. You have to be very careful how you write this if you just use your calculator. Because if you, the calculator and negative signs and squareds can be very difficult. So you need to work it out. -5 minus 3 is -8 squared. Plus -3 minus 6 is -8 squared. That means you've got 64. You've got the square root of 128. Hold on a second. Oh, I lied to you. I was thinking about a problem we did earlier. -3, -6 is -9. That means that this is 81. And when you add those together, it is 145. The square root of 145 is your answer. Now you could approximate this to like 12 if you needed to. All right, classifying these. This triangle here, you can't quite be sure whether it's an scalene, isosceles, or equilateral, so you have to actually perform the distance formula twice. Let's start with AB. The x's are 2 and 5. So 2 minus 5 squared. Now the difference of the y's, 3 and 7. So 3 minus 7 squared. And if we go ahead and look at this, 2 minus 5 is -3. 3 minus -4. So you end up with the square root of 9 plus 16. The square root of 9 plus 16, that's the square root of 25, which is 5. So this side here should be a 5. If all 3 lengths are the same, then it's equilateral. If only 2 of them are the same, then it's isosceles. If none of them are the same, then it's a scalene. So we're going to skip a few steps when we do B to C. Because remember, we're dealing with the difference. So for B to C, the difference between the x's, here, x is 5, x is 6, the difference is 1. Then from 7 to 1, what's the difference between 7 to 1? That's 6 squared. So we end up with 1 squared is 1 plus 30, that's 37. the square root of 37. That's what this part right here is, square root 37. So we already know that it is definitely not an equilateral. Let's look at AC now. The difference between the x's, 2 to 6, that difference is 4. The difference from 3 to 1, that's 16 plus 4, square root of 20, which is the square root of 20. Which, are any of these sides actually equivalent? You say no, so that it is a scaling. All right, checkpoint. Find the distance between those 2 points. So you're using the distance formula. So anytime you do this, I recommend actually writing out the formula. So that you can, so that it helps you remember what's what. And now let's look at what is the difference between -7 and 5. Well, the difference, well, -7 to 5, well, -7 to 0 is 7. 5 more is 12. The difference between 3 and -2, well, 3 to 0 is 3, -2, that's 5 more, plus 5 squared. So we've got 144 plus 25. That gives us the square root of 169, which is equal to 13. Here's another triangle. It might be helpful if you actually drew the triangle. So we're going to put 2, 1, 4, 6, 7, 3 here. Now, all we're doing is the distance formula 3 times. So let's do A. Let's do A side first. Should be 7 differences of the x's. 7 to 2, there's a difference of 5. 3 to 1, that's a difference of 2. So what we've got is a square root of 25 plus 4, the square root of 29. Let's do side B. Square root of differences of the x's, 2 to 4. That difference is 2 squared. The difference between 1 and 6 is 5, so 5 squared. That's the square root of 4 plus 25, or the square root of 29. So far we have canceled out the choice of scaling. But you still have to check to see if all sides are the same, or if just 2 of them are the same. So let's use, now, side C. What is the difference between the x's? 7 to 4, that difference is 3. 3 to 6, that difference is 3. So you have the square root of 9 plus 9, or the square root of 18. 2 of the sides are the same. So if 2 of the sides are the same, then you would say this is definitely not an equilateral. Isosceles is our only choice. All right, line segment, a midpoint is equal distance from the segment's endpoint. The midpoint formula describes the midpoint of a line segment between those 2 points. And here's the formula. In words, each coordinate of M is the mean of the corresponding coordinates of A and B. And that's what I said, it's the average. You are averaging the x's and you are averaging the y's. So looking here, we're finding the average between the x's. So you take -6 plus 2 divided by 2. Well, that becomes, let's see, -6, that's -4 over 2. Means -2 is my average x coordinate. Now look at the y's. Averaging the top, so 5 plus -3 over 2. That means you've got 2 over 2, which is 1. So -2, 1 is my average point between those equations. So, same thing. Practice writing the equation so you don't forget. And then let's find the average. So -4 plus 2 over 2. That becomes -2 over 2, which becomes -1. The average of the y's. 1 plus 3 over 2. That's 4 over 2, which is 2. That is how we find the midpoint. So here is a checkpoint for you to look at for this. Find the midpoint between those. So practice writing out the formula. Add the x's together, -6 plus 1. That's -5 over 2 is the x midpoint. Now the y's. Six over 2, -5 halves, 3 is the solution here, or is the midpoint. All right, a couple things you need to look at for number 4 is remembering what it means to be a perpendicular, what it means to be a bisector, and so on, and how to write an equation. You're going to need to know the slope equation. You're going to need to know the point slope form. And you're going to need to know that perpendicular lines have opposite reciprocal slopes. So this is a three-part problem. Number 1, the first thing you have to do is you have to find the midpoint. So for us, x1 plus x2 over 2, y1 plus y2 over 2. Find those. So the sum, -5 plus 3 over 2, that's -2 over 2, that's -1. Find the midpoint first. Now the y's, let's do -2 plus 6 over 2, that's 4 over 2, that's a 2. So now our midpoint, we have an equation that bisects this graph, this segment at -1, 2. As a refresher, here's a line segment halfway. Any line that goes, through there, through this midpoint, is a bisector. Now, step 2 is to come up with you need to know the slope of original. Slope of original. The slope of the original, we use the slope formula. You're finding the differences of the x's, dividing by the differences of the y's. So, the y's, y2, -2 minus 6. The x's, 3 minus -5. So, -2 minus 6, -8 minus a minus 8. So my original slope is -1. All right, -1 is the original slope. Therefore, the perpendicular line to it is the opposite reciprocal. So, -1/1, you flip the fraction and make it the opposite. So, -1/1 becomes 1/1 or +1. So now you have the equation. You have the point. You have the perpendicular slope. So now you use point slope. So we plug in a y value. So y minus 2 equals 1x minus minus 1. Minus a minus is a plus. Distribute the slope in. And then add 2 to both sides. And now it's in mx plus b form. All right. That pretty much takes you through everything you need to know for this section. Good luck on the homework. We'll see you next class.